This is the solution video for section 8.1, problem number 5. All right, so the directions say find the area of the region bounded by each set of graphs. Now, remember, it says find the area. It does not say set up an integral that could be used to find the area. So we actually have to carry out the integral. All right, so I have y squared equals 4 plus x, and we have y squared plus x equals 2. So we have to figure out what these graphs are, right? Now, we could solve them for y. We could say, okay, well, y is equal to plus or minus the square root of 4 plus x, right? We could do that. And then over here, we could do the same. We could say, okay, well, y squared, if I subtract x and then square root, I get y is equal to plus or minus the square root of 2 minus x. All right, so we know that we're looking at like a square root function that's been shifted, and this one, a square root function shifted, but that's reflected. Now, we could also write them in x equals form. So this would be like x equals y squared minus 4. And this one would be x equals negative y squared plus 2. Now, I choose to think of these in the x equals form because I think it's a little easier. So x equals y squared minus 4. Now remember, you should be doing these without a calculator. These are non-calculator questions. All right, and so x equals y squared minus 4. That is a basic sideways parabola, y squared, but then I'm subtracting 4, so I'm shifting it to the left 4. So I get that. Okay, and this is shifted to the left 4, so this point is negative 4 comma 0. Okay. All right. Now, the other way, all right, this one is negative y squared, so it's a parabola facing to the left that's been shifted to the right 2, and so I get this picture. All right, and so now, okay, you can see here that these are going to intersect at 2 places. All right, now, which is going to be easiest, to use a dx or a dy? Well, a dy is going to be easiest because no matter where you draw the dy, this curve on the right, the x equals negative y squared plus 2, is always the one on the right, and this curve, the x equals y squared minus 4, is always on the left. But if you were to try to use a dx, let's just say here's a dx here, and here's a dx here, right? Notice these dx's have different upper and lower boundaries than each other, and so in general, we don't want to do that, all right? And so I'm going to use the x equals equations, all right? And I'm going to use a dy rectangle. All right, so dy rectangle with an x equals. All right, so that means I'm going to integrate with respect to y, right? So that means my x equals equations, okay, can only have y in them. All right, so now I'm going to take the right-hand boundary, which is the negative y squared plus 2. So I'm going to take negative y squared plus 2. And I'm going to subtract the lower boundary, which is the y squared minus 4. All right, now we're going to integrate from the lowest y value to the highest y value. Oh, well here, since I had to draw the graph, I also have to come up with what these points of intersection are. So how do I do that? Well, I would actually set the two equations equal to each other. So y squared minus 4 is equal to negative y squared plus 2. And so now we have a relatively easy equation to solve. Let's add y squared to both sides, so I get 2y squared equals, now I'm going to add 4 to both sides, so I get 6. So I'm going to divide by 2, and I get y squared equals 3, which means that y equals plus or minus root 3, right? So plus or minus root 3, so that means the y value of this intersection is negative root 3, and the y value of this intersection is positive root 3. Remember, it's the y value. We solved for y. So do you need the x? Well, in this case, you don't, but you should be able to find it. And remember, they have the same x value. All right, so pick either one of the equations. X equals y squared minus 4. So y, which is root 3, or negative root 3, either way, squared minus 4, right? So it doesn't matter which one you have because you're squaring it. So x equals square root of 3 squared is 3 minus 4. So we get negative 1. So the x value is negative 1 here and negative 1 here because it didn't matter which one we plugged in. All right. So anyway, now I'm going to integrate from the lowest y value, which is negative root 3, to the highest y value, which is positive root 3. All right. So now let's simplify before we try to integrate. All right. Why would I want to simplify? Well, because I have a negative y squared and I have a minus y squared. So together we get negative 2y squared, right? And then I have a plus 2 minus a negative 4, so I get a plus 6 dy. All right, so now it's going to be a little bit easier to integrate there. All right, so I'm going to integrate negative 2y squared. So that becomes negative 2y cubed over 3 plus the integral of 6, which is 6y, from negative root 3 to positive root 3. All right, so now let's plug in. I get negative 2/3 y cubed, so that's going to be positive root 3 cubed plus 6y, right? And then I get minus negative 2/3 times the negative root 3 cubed plus 6 times negative root 3. All right, and sorry, I forgot to plug in a value here. All right, and so this should be a positive root 3 as well. All right, so now I have negative 2/3, and the square root of 3 cubed is root 3 times root 3 times root 3. So I get 3 root 3. All right, so now the 3 is reduced, so this would just be negative 2 root 3 plus 6 root 3. All right, then I have minus negative, right? So I'm going to keep that in there. All right, so I have negative 2/3, and then I have negative root 3 times negative root 3 times negative root 3. So that would be, there's a negative overall, right? And then I have 3 root 3. And then I have minus 6 root 3. All right, so now what do I have? Well, this is a negative 2 root 3 plus a 6 root 3, so that's a 4 root 3. And then I have minus. All right, now here I have a negative times a negative, so those are going to reduce, and a 3. So I have minus a 2 root 3. And then I have a negative 6 root 3, but I am subtracting that, so it's plus 6 root 3. So I have a negative 2 root 3 plus a 6 root 3. So 4 minus 2 is 2, plus 6 is 8 root 3. So 8 root 3 is the area of that region.